In the last video you watched, you should have seen that we figured out the area of this hexagon by drawing 6 congruent triangles and then taking one of those triangles and redrawing it and finding the area of that triangle. We're going to do the same thing, but we're going to take away all the numbers. So we're just going to call the side length to be S, and that's it, instead of 8 inches. We're going to do the same thing and see if we can't create a formula for that. So here we go. We're going to draw 6 congruent triangles that come from the center of this hexagon. We are then going to take one of these triangles and redraw it. The base is S because we know it was a regular polygon, so all of these sides were the same. We know that it was an isosceles triangle because all of the radii coming from the center of that circle were the same. We know that each of these arcs is congruent because each of those chords are congruent. And we figured out last time that if you had 360 degrees and split it evenly by 6, each of those arcs is going to measure 60, which means this central angle, which is the same angle in our triangle, is also 60. All of that we knew, and none of that is going to change. The only thing we're going to do is we're going to use S as the side of the polygon. So as we continue, we're going to find the area of this triangle. So the area of this triangle will equal 1/2 the base times the height. Since we don't have numbers, we don't have to worry about finding them. Let's just draw the height from the top of the triangle straight down, makes a 90 degree, and we're just going to call that the height. The base actually measures this side length of S. So my formula for my triangle is going to equal 1/2 times that side of S times the height of H. But I have 6 of those triangles, so the area of my hexagon is going to equal the area of that triangle times 6. So let's take 6 times the 1/2 times S times the height. And while you're looking at that, nothing may strike you as very important, but to me it does. You're taking a hexagon, and in that formula for area is 6 times S. And remember, multiplication can be done in any order, so I'm going to write it like this. I'm going to say that the area of that hexagon is equal to 6 times S times 1/2 times the height of that triangle. Because 6S is the same thing as the perimeter of the hexagon. Because if you look back at the hexagon, each of these sides measured S. And 6 times all of the sides will give me the perimeter of that hexagon. So I'm going to change my formula to read the area of a hexagon is equal to 1/2 times the perimeter times the height. And the cool thing is, it doesn't have to be a hexagon. It could be a pentagon. It could be a triangle. It could be a square. As long as it's regular, this is going to work. Because instead of 6 times the sides in a triangle, it would be 3 times the sides. In a square, it would be 4 times the sides. A pentagon, 5 times the sides. It's always going to be the perimeter times the height of that triangle. So what we're going to do is we are going to define a very specific word. We're going to go back all the way to the hexagon. I'm going to erase all this stuff. We don't need it anymore. We figured out the area is going to equal 1/2 the perimeter of this hexagon multiplied by the height of the triangle. But the height of the triangle was created by starting at the center of the circle and drawing straight down to the hexagon. Now, this is not a radius, so don't call it a radius. It's not making it all the way to a point on the circle. This height is the height of the triangle. We're going to call it the apothem. And the apothem is simply the segment from the center of the circle to the side of the polygon. Or you can think of it as the height of that triangle. So the area of any regular polygon is always going to equal 1/2 times the perimeter times the apothem, which we usually write as 1/2 AP. This will work for every regular polygon ever. And this is the formula you're going to see me use in the examples that I do in the next videos.